Hello. Today I'd like to introduce you to the DPR Construction Regional Phoenix office. It's a fantastic example of the potential of revitalization and sustainable design. It's a 16,500 square foot building. It was completed back in October of 2011, and the final costs were about $150 per square foot. So the design team, the two main firms involved in the design of the DPR Phoenix office were Smith Group and DPR Construction. DPR was the building owner and the contractors, and Smith Group represented the architectural and engineering teams. There were also some other groups involved as consultants and energy specialists. The image you see there on the right is not from this building, but it's from another building that Smith Group and DPR collaborated on as well. And they do have a history of collaboration on successful zero net energy projects, such as DPR's Sacramento office and Mid-Atlantic headquarters. So the design approach for this building. DPR had already been located in Phoenix, Arizona. Their lease on their current building was up, and they were looking to relocate. And they sort of set out a challenge for themselves: a zero net energy building in the desert. And they also wanted to use only strategies that would meet a 10-year energy return target. So they ended up selecting a building that was abandoned for a couple decades. It had previously been an adult-themed boutique, sort of in a re-emerging area of Phoenix. And they selected this building to demonstrate the potential of revitalization, as well as its commitment to the community and to the area. And so with the combined efforts of DPR and Smith Group, the result was the first certified net zero energy building by the International Living Future Institution, which was the first in Arizona and the second in the United States. So the second building certified net zero energy in the United States. The main focus of this project was on the building performance. The site was not too large. It's mostly just the building. The main space here is in the background picture there. It's a very large open office plan with several conference rooms, training rooms. There's a exercise or gym space. There's a break room. You take a look at the bottom two images there. One of those is a conference room or sort of a meeting space, and the other another meeting space, and that's actually a roll-up door, kind of like a garage that is basically a retractable wall, and it allows the outside in on those cool days. So here's just to give an idea of the location of the building. It is, I think, classified as urban outskirts. It's not in a very super high density urban area, but it is in the urban sort of center of Phoenix. It's located very close to the Phoenix Sky Harbor International Airport, which you can see a couple of runways there in the bottom left. Within a quarter mile of the building, there's a light rail station which has access directly to the airport and to Mesa, Tempe, downtown, West Phoenix, which helps to cut down those transportation costs. So the sustainable strategies that were used in the construction of this building, or not the renovation of this building, with the overall goal of zero net energy, they needed to reduce the energy load as well as produce renewable energy. So all the renewable energy is produced with a solar power system that is tied to the grid, meaning that any excess energy that's produced goes back into the grid, and then you can also pull on the grid when you aren't producing enough energy. Solar tubes are really quite an impressive device. They're natural daylighting. They were able to successfully cut down lighting loads by 70%. They also right-size the HVAC system, reducing more energy loads there, with more efficient, as well as more efficient mechanical systems. They employed several strategies to help passively cool the building and also further reduce those HVAC loads. Solar chimney, evaporative cooling shower towers, which I'll cover in the next slide, big ass fans, and 87 different operable windows. There's also a vampire switch, which we'll get to, and a building monitoring system called the Lucid Building Dashboard, which is real-time monitoring of building systems, energy usage, and energy production, as well as increasing the insulation of the building. So in the bottom left here we have the solar chimney, and the way that works is essentially it heats the air in the chimney, causing it to rise, and it creates a draft that pulls more hot air out of the workspace and dissipates out, and which helps to cool the space. The solar tubes there on the, you can see in the bottom left again, those transparent domes set into the roof. Those actually are, they focus the sunlight and create quite an impressive lighting fixture. On the bottom there's the vampire switch, and essentially what that does is it turns off all non-essential energy loads. So the last person out is going to hit that, and it reduces the overnight energy loads by up to 90%. So here we have some interior shots of the building. One is a conference room, and another is another angle of the main office space. Those overhead lights are actually the solar tubes, and they are as bright as overhead lights. It's really quite impressive. It uses like really advanced optics and reflective materials in order to get that effect. Big ass fans as well. That's the name of the company, and essentially they're just really big fans, and there are 12 of them throughout the office, and they're much more energy efficient than smaller high-speed fans. So living walls are also encouraged on the outer walls of the courtyard, which helps to reduce the heat island effect. And operable windows also work in tandem with the Lucid Building Dashboard to help regulate the indoor temperature. Overall, the combination of these sustainable strategies was hugely successful. As I mentioned before, the DPR Phoenix office was the first zero net energy building in Arizona, proving the potential of sustainable design at relatively low cost. If you take a look at the 2014 energy data, you can see the net energy generated, a positive 3.4 about megawatt hours. The building uses about 7.5 kilowatt hours per square foot per year, which is about half of the average office building, according to the Energy Information Administration. So in order to determine how effectively these strategies could be implemented elsewhere, we have to consider the context of the site. Phoenix, Arizona is the 6th hottest and the second driest city in the United States. So air conditioning loads during the summer are going to be significantly higher than suburban New York, and heating during the winter will be significantly lower than the, well, suburban New York again, sure. My grandmother lives about an hour north of New York City, and she doesn't even have air conditioning. Or she has heating, but no air conditioning, and this is not uncommon for her area. Phoenix has a very high UV index with limited cloud cover, which means that photovoltaics are going to produce energy much more effectively, and it also makes those solar tubes a viable alternative to artificial lighting year-round. The location of the building in sort of the urban area of Phoenix is also going to contribute to the heat island effect, but creating more heat and increasing the load on the HVAC systems. But it also means that there's significant infrastructure that allows the solar power system to be tied to the grid. In places with a similar climate, the specific solutions used in the DPR office are clearly effective in reducing building load and achieving zero net energy. But there are also other general strategies that they utilized here that should be considered if you want to make any building more sustainable. If you're looking at replacing HVAC or in new construction installing HVAC, right-sizing those systems is very important in eliminating unnecessary energy loads. Any other building energy monitoring system is a great tool to help collect building energy data and implement solutions to help reduce energy usage, provided that it is compatible with your systems. I'm not exactly sure how what that would look like, trying to incorporate that into an already existing system. The vampire switch also is a very straightforward, simple tool that has a significant effect on reducing the overall energy load, but again, this might be difficult to implement in an already existing, occupied, in-use building. Overall, I believe the DPR Phoenix office is a fantastic example of urban revitalization combined with exceptionally sustainable design. It was an ambitious undertaking, the first zero-net energy building in the desert of Arizona, but it has proven the potential of creativity, collaboration, and commitment to sustainability. And I expect the lessons learned and the data gathered from this project will and has already helped a new generation of sustainable construction. Thank you.